Hello, good evening, everybody. I hope I'm audible as well as the screen is visible to you. Please give me a thumbs up so that we get going. Yes. Yes, Raghavan, did you say something? Echo. There's an echo. Okay. Okay. Please confirm it to me now. Is there still any echo? Okay. All right. Okay. So make sure that the screen is legible to you, that you're able to read what exactly is there on the screen, and that you're also able to hear me properly. All right. So we are starting with unit 5. So we are starting with unit 5 from today, which is spatial data handling and analysis. The first topic that we are discussing is data input methods. There are essentially three methods that we are discussing, of which the first one is digitizing. That is the most basic method that anybody uses in order to add any data into GIS system. And the second method is scanning. Often we will have some data set in the form of a map, and digitizing the entire map will require for us to first scan it. There could be some historical data set as well, and that is not available readily in a digitized form, in an electronic form. It is essentially hard copy, so we have to first scan it such that it comes into our system, and then we will be able to extract all the information whichever that we are interested in. And the third method that we will talk about is a field oriented method, wherein as we go into the field, we collect certain information, maybe a site that we visited. So, what are the particulars about that site? What are your observations that you made? Or if there was any structure over there, then you have mapped its contact and things like that. So, all these three methods we are going to discuss, and we'll try to move on to the next topic as well. Okay, so unit 5, spatial data handling and analysis. So we will talk about how to input GIS data within within the system, what are the different methods available, and then we will also talk about how to handle this data set once it comes into the GIS system, and also then talk about how this data, in what all very basic and most important methods, techniques through which we analyze these data sets. Often there are multiple other methods also that you're using, but these are the most important ones that you look into. Let me just come back and show you the entire content of unit 5. Okay, so unit 6. So unit 6 is spatial data handling and analysis. Our objective is to understand GIS operations. The first topic that we are discussing is data input methods, where we are discussing digitization, scanning, and GPS. The second topic is database management in GIS. How do we handle all the data set? How do we give it a name and things like that, and then move on to the spatial data analysis, and very importantly we look into the attribute queries. All right. So the first method is digitization. Anytime that you have a satellite image, or even if you have a scanned map, maybe a topo sheet or anything of that sort already, it is a digitized form. You're not able to measure any areas, you're not able to measure any length, you're not able to count the features very effectively without any error. And in these cases you go for something called digitization. So most of the time, rather all the time, you will see digitization will lead to a kind of data set that we call vector data set. Okay, we have already seen two types of data sets into GIS. One is raster and the other is vector. Raster data set is the photographic data set, and vector data set is such a data set that has polygons. It is represented by lines and points. So these are the three most basic features that represent vector data set. So when it comes to digitization, we essentially go through several steps when we digitize any kind of data in GIS. So of this, the first one is always going to be data preparation. So first, what you do, you select and prepare the images or maybe the maps that you require, from which you want to extract some data set. For example, here you see a satellite image, and from there this person is trying to extract the buildings, right? So that is his objective. For that, what the person has done, the person has brought satellite imageries, and these satellite imageries then he is going to use for preparing the data set. So here at the very first step, we prepare the data, that is we bring the maps or the satellite imageries that we are interested in drawing information from. And the next thing that we do is georeferencing. Often what happens is that even if these satellite data sets are mm, um, orthorectified and something like that, or even if they are drone data sets and things like that, we might be already having a base map. A base map could be the oldest map or could be the youngest or the very recent map. With respect to it, we have to ensure that our other data sets are properly overlapping. In order to do this, we go through something called georectification. You have previously discussed it with me while we were talking about geometric corrections. So this is the second step. First we bring in all the maps from which we want the information, then we go for geo-rectifying it, geo-correlating it, or geo-referencing. All these are synonymous. They're used interchangeably in many aspects. Now, once this happens, then we go for creating a new layer. This new layer is essentially either points or lines or polygon. For example, if you want to find out what is the area of a lake, then you will go for creating a new layer, that is polygon. But if you want to mark a road, then you will go for using a line for digitization. If you want to count the number of trees that are present in a given property, then you will go for creating a layer, that is point. And once this happens, then once you have created the layer, then you go for digitizing the feature that is of your interest. Now, one step beyond, some of us might only be interested in digitizing, but some of us might be having some prior information about these features. So we want to add that information as well into these digitized features. For example, let me give you one example. Let's say there are multiple lakes in a region. There are, let's say, 15 lakes in a region. And not all of them are, pure, in the sense that some of them are contaminated. Some of them are contaminated with oil. Some of them are contaminated with a lot of phytoplankton bloom. Some of them are contaminated with maybe fish that is getting killed, dying fish and something like that. So some of the lakes are very pristine, uninterrupted and things like that. In some ponds you will see there is a lot of sewage that is getting drained. So all these ponds have different character to them, and this is the character that you want to add to these digitized features. In this case it is lake. So to each lake there is different information. You want to write where exactly this particular lake is located. In association to this lake, what all is present. If there is a petrol pump nearby and this lake has a lot of oil that is floating on top of this lake water, so then you would want to make that particular information written into your data sets. And that is where we come in, that is where we talk about attributes. These are the characteristics that you add to the features that you are extracting using digitization. And once this happens, you want to also ensure how accurate this data is, or even if there is some error, you would want to resolve it before you go for utilizing that data set. So that is what comes under quality control. And then comes you save it, and if you want to export it, you go for exporting a map out of it that you would want to add into a report or news article or something like that, or send it to somebody else. Maybe you would want to send it to your supervisor or things like that. So that is where comes into picture saving and exporting. Let's just recollect what exactly digitization is. Digitization is a process in GIS through which we are converting the hard copies of maps or such a data which is essentially available as analog information. We are converting it using a scanned photograph or maybe satellite images. We are using it to extract the information that we are interested in. Essentially, how we extract it? We extract it in a vector format. Vector format includes points, lines, and polygons, which can be very efficiently stored. We can also edit them because raster data cannot be edited. Vector data can be edited, and because we can store them, edit them, we can also go for an advanced level of analysis within the GIS domain. All right. Let's just ask you this question. Is digitization clear to you? Is digitization clear to you? Often we will definitely know that digitization is very, we have a satellite image, we want to extract some information, we have to choose from these three features, whether it is going to be a polygon or it is going to be a line or it is going to be a point. And once we know which feature we are going to use, we are then going to mark that feature using these points, polygons or lines onto the map. Okay, and that will be saved as a separate layer. But have a deeper understanding about what is the purpose of this digitization, how it is different and has benefits over that of raster data set. So these steps we have to remember, these 7 steps. One is data preparation, where we select which data set we require. Then we geo-rectify it. We will not directly go for extracting information. It has to be spatially correct with respect to the base map that you're using, because of which you have to go for georeferencing. Then you create a new layer, and then you digitize the feature that you want to digitize. And then if at all you have some more characteristics, some field information that you have collected with respect to that feature, then you add it into that feature, you store it in that feature, and then you check for if there is any error, you check for what is the accuracy, and then you go ahead and save it. And if at all you require to send it across to somebody else, you will export it. Okay, just give me a thumbs up if you have understood digitization. If you have any query, please drop them. You can also unmute yourself and talk about it, right? So digitization is wherein we have some information that is present in a map or is present in a satellite image, and we want to extract it. We want to only note down that information with respect to its configuration, what is its shape, what is its size, its aerial extent, its exact location, right? Its aerial coverage and things like that, its orientation as well. So all this will come into picture when we are talking about digitization. All right. We will take up some questions. So if you have not written your question as of now, but you're thinking of writing it, please go ahead and write it. Not a problem. Let's talk about the second method of data input, which is scanning. Now, often what happens is that satellite data is not really covering the kind of temporal coverage that you are trying to study. For example, let's say you are trying to study how was the forest cover in 1901. Satellite data was not there then, isn't it? So, what do you rely upon to find out forest boundaries? Can anybody tell me? Let me repeat the question. What is the question? I want to study how the forest cover has changed for a specific region in last 100 years. Okay? In last 100 years. So satellite data is not of my use. A satellite data I have from 1972 onwards, but in that too in 1972 it might not even be there. Let's say from 1973 onwards the data set is available for me, satellite data, Landsat 1, Landsat 2, 3, 4, 5, 7, 8. Okay, from then onwards we have the data set, satellite data set. Before that I don't have any satellite data. So what will I go looking for if I want to know what was the forest cover, where the forest boundaries were located in 1901? Where do I go? Can anybody tell me what should be my uh, resource from where I'll be able to get this information? Can anybody tell me? Yes, let me give you 15 seconds. Yes, old maps as secondary data from government offices or NGOs. Yes, very correct. Right? And can anybody name any of these documents, any of these maps? What kind of maps these are? What kind of old maps these are? Can anybody name them? Topo sheets, yes, very correct. So topo sheets, I will go for looking. I will visit Survey of India. I mean, and I will try to identify if they have a topo sheet for the same region that I am interested in. Now, these old maps, they are available as hard copies, isn't it? All of them are available as hard copies. They are not available as digitized maps. How we would otherwise look into. Yes, cadastral maps. Correct. Very correct. So mm, old regional maps, old cadastral maps, old village maps, or if we are looking at old town planning maps, topographic maps. So these are the maps that I will rely upon in order to identify what was the forest cover in 1901. Now, these maps, when they were prepared on a scanning table. Okay, they were prepared by a cartographer. Um, they were handcrafted. However, there were no digital copies that were made at that time because the computers were not available, and these are available as hard copies, isn't it? So in this situation, whenever I want to use that map, now that could be a different case wherein these maps are already digitized and they are made available to you. That's a different case. But if I want to start from the very start, that is, I have a topo sheet that has not been scanned, what will I have to do? I will have to scan it. So this is first requirement. Some old maps, some historical maps are there. They have not been converted into digital copies. So if there are any contours like this, no, then they are not marked. They are their location is not marked. They are not geo-rectified. They are non-spatial data. They're basically just printed maps. So what I have to do, I will have to go for scanning. So these are non-digital maps. Okay, these are non-digital maps. Often it may also be to do with such a data set that is prepared by somebody else and has been published in a research article, or it has been published in any thesis or dissertation. It has been published maybe in some conference paper. It has been published on a newspaper or any magazine and something like that. So to that map, you do not have any direct access to. Okay, so in that case, what do? You go for scanning it yet again. So if you have, let's say, if somebody is trying to explore geology of Goa, right? So somebody else has already made the map, and now that map, because it is just present as as a copy maybe in a textbook, I would want to go for scanning it so that it becomes available in my computer, right? And then I can go for geo rectification and then extract the data sets and things like that. The third is base map preparation. Often the base map that we use is the oldest map that is available. For example, if I take you back to the same problem wherein I'm trying to study what is the forest cover, for last, how the forest cover has changed for last 100 years, right? So in this case, I would want to use base map, which is the oldest. So if 1901 topo sheet I have, then I would want to use that as a base map. So that is my base map, and how the forest cover has changed through time, that I'm able to note down. right? So in this case also I will have to go for scanning. Just give me a second. Correct. Okay. And then I would also want to update some special information, that is this map that I have used, that is the topo sheet that I have used from 1901. What I want to do is I want to see what was the forest aerial coverage back then. So what do I have to do? After scanning it, I have to mark the boundary of the forest, if that forest was present in patches, right? So then those patches also I have to mark. For example, here if you see, this seems to be more of a continuous forest, but here you will see some small patches. So you would want to mark them. You want to import that spatial information about the forest cover onto your GIS software, such that you will then compare it with the other forest cover at different point of time for the same region, right? So in this case again you will require scanning. Then you would also want to share this information with somebody. Let's say this information that is available in some cadastral map as to which were the settlement areas, which were the agricultural areas, which were the orchard areas and things like that. So what do? You go for scanning it, and then you want to share it with somebody, isn't it? Now as well, if you want to look out for any cadastral map for any region, any district or any village, then you will essentially get a scanned image only, that has not been converted into GIS data. So it will be just present as an image. So you have to go for geo-rectifying it. You have to go for giving it a spatial reference, that is, it is going to be non-spatial data, you have to convert it into spatial data. So one is sharing, other is archiving, because you want to store it, no? For if somebody 100 years after wants to use this data, then they should be having access to it. So how will they be having access to it? Only when you have converted into a digital data. That is, if you have already scanned it, it is available in the computer, it is better for storing. Otherwise, if it is a paper map, might be susceptible to a many risk, maybe termite infection, or maybe lost somewhere, tone, wear and tear, these and that, all that problem is there. So in order to store it and also to share it, you again require scanning. That is the most efficient way. And finally, why are we scanning it? Because we want to integrate the information that is present within that map into the GIS system. Okay, and that is why we are going for scanning it. So what exactly is scanning? Yet again, in GIS, it is a process by which we acquire data. Okay, some data is available in the form of printed maps and things like that, or it is available as a map that somebody else has proposed. It is present as a hard copy. You want to convert it into a soft copy such that it is available within your system. You don't have to move around with the hard copy, and that is why we go for something called scanning, which is a data acquiring process within the domain of GIS, by which we convert the hard copy maps or images, maybe satellite images or stereo pair images, we convert them into digital raster format. What exactly is raster? Raster is made out of pixels, isn't it? Raster is made out of pixels. It is photographic data. Such that what we are doing, we are able to extract the information that we require from it. So here you see a scanned map. Okay, so this is definitely a hard copy, because you will see that some handwritten text is also written on this particular map. You will also see some markings on these maps, some lines that are drawn, that is different divisions that are made on these and things like that, that you see. And it has been converted into a digital copy. That is how I'm able to show it to you on my screen. So that is about scanning. Just give me a thumbs up if you have understood scanning. Okay, great. Hmm. This is something that is very essential for you to know. Essentially, if your work requires a thorough inspection of the field, if you are an architectural student, or you are into town planning, or if you are into mapping topography of a region, or if you are into afforestation projects. I'm just telling you those things that I have received from you. Or if you are into conservation, so these are the, or essentially if you are into geology, wherein you're trying to map different features or different rocks or different mineral zones and things like that, your work is very much grounded in the sense that you have to make a site visit and collect some information that is present on the ground, right? So you make some information, you collect that information, bring it and drop it into GIS. This is what you are doing. So when we say GPS, it is a survey technique. We essentially go surveying the region, okay? And it is a very precise satellite based method. Precise in the sense, when you go to the field, if I have collected the data using GPS survey and I'm telling you that at such and such location, such and such feature is available, then when you plan to visit that location, you should not be hovering here and there. You should be reaching the same exact position, right? Within a distance of just 1 meter, within a diameter of just 1 meter, that location you have to identify. Such precision has to be there whenever we talk about GPS surveying. So this is where we make use of GNSS satellites. um, and what they do, they help us in identifying our precise location on the entire planet, also to the extent that it tells us what is the elevation of the location above mean sea level. Okay, so such precise is this surveying method that takes into consideration GNSS services. Now, so we get to know what is the latitude, what is the longitude. We also get to know what is the height or the elevation on the Earth's surface. Now, there are essentially two types of methods that we are going to talk about. One is GPS surveying, and the other is DGPS surveying. Okay, so these are the two things that we are going to talk about. One is GPS surveying, other is DGPS surveying. Let me beforehand tell you what exactly is GPS and what exactly is DGPS. 8 minutes. All right. So, what is GPS? It is Global Positioning System. When I say system, it means it is comprised of multiple components, and these components are essentially GNSS satellites that helps us in global navigation satellite system. That is what it is called. It's a constellation of multiple satellites that are hovering above the atmosphere, above the planet's surface in specific orbits, and they keep contacting one another, finding out what is the distance between them and what is the distance between a transmitter that is located on the planet. So we have GNSS constellation satellite system, and then we have a handheld GPS that essentially works as a transmitter and as a receiver. So here you will see one location that is known point. We have known what is the latitude, longitude, and its height above that of mean sea level, or the datum that we are considering, and the satellite knows what is its exact location. And then the surveyor moves around in order to map a feature, and he keeps collecting the information of the points with respect to this particular location. Okay, and he keeps on moving along that particular region, and then comes back and encloses an area, if at all that is what his intention is. Or if he's trying to map a linear feature like that of a road, or maybe a fault, or maybe a river, maybe a paleo channel and something like that, right? So he keeps on making multiple observation along the feature on the ground that he's trying to map. And what the satellite does, it keeps recording its location with respect to the known point. All the unknown points, their exact location with respect to the known point is noted down, and this information is gathered within the handheld GPS. Atrix 10, Atrix 30, these are the Atrix 20, these are the most commonly used GPS handheld systems. You might also be using the same ones. And then this information that is stored within the receiver, within that handheld device, can then be transferred into the GIS software. Could be QGIS, could be ArcGIS, or could be LWIS, could be NV, could be ERDAS, could be ArcGIS. All these softwares will be compatible with this GPS system. It essentially stores your data in the form of a text file, or in the form of a gridded data, in the form of a table and things like that. Okay, so that is about GPS. Just okay. Now coming to DGPS. The full form of DGPS is Differential Global Positioning System. How many of you have heard of DGPS? Just give me a thumbs up if you have heard of DGPS. Okay, so we have GPS, Global Positioning System. You go around in the present time, you go around, map your region, and that data gets stored into your handheld device, and you can then transfer it into GIS software where it will be recognized and imported into the system such that it becomes available for you to analyze, for you to store, for you to add any attributes and whatever that you want to it. Now, DGPS is wherein you are trying to study the same area, okay, multiple times, and you are not only interested in its aerial coverage, you are also interested in if at all the height has also changed, that is the elevation has also changed, to what extent the elevation change has occurred. Even if it has occurred at a scale of few centimeters or few millimeters, you are interested in identifying it, and that is where you go for using differential global positioning system. What do you use global positioning system for? You use it to identify the area of a feature or the length of a feature, to map it basically and bring it into GIS system. GPS also does all these. In addition to that, it also helps you in noting down if there were any elevation change temporarily with the changing time, if there was any elevation difference that has taken place. And this is what makes DGPS a very sophisticated, a very complex and highly efficient system that will help you in monitoring real time, uh, sorry what is that, real environmental elevation changes. Now, why we are interested in the elevation changes? We are essentially interested in the elevation changes in the studies like that of landslide. If we want to know such certain regions are more susceptible to landslide, then you will see that there is subsidence. Or if you are trying to study those areas which are suffering heavy groundwater withdrawal, so in those regions you are interested in it. Wherever there is excess of groundwater removed, what happens between the soil grains, whatever water was present, it is pumped out, so it is vacuum, no, so it has to collapse. So what will happen to the entire ground? It will collapse, it will subside. Very essentially, if you have very recently heard of Joshimath sinking, then that was the case. Because of heavy groundwater withdrawal, there was subsidence. Then earthquakes. With earthquake, what happens every time the ground also changes, becomes destabilized, isn't it? So in order to understand how a recent earthquake has altered the ground elevation, so there as well we are using this. If we want to study how to what extent, the flood has changed the elevation because a lot of debris came and settled down, so now the ground has elevated, so this is where we are using. We also use it in coastal planning, where we are trying to study which are the regions along the coast that are eroding heavily. Sand is getting eroded. So these are the places where we are using DGPS.